going to do this example. Limit as z goes to 0 of the conjugate of z over z does not exist. But first, a reminder of some calculus, basic calculus. Here's the basic idea that we're going to use for this. Right? If I have a function, and the function looks like this, right? So if this is the point, I don't know, this might be the point 3, this is 1, and this is 2. Here we say that the limit, if this is the function f, limit of f as x approaches 3 does not exist. Why do we say that? Well, because the limit from one direction is 1, the limit from the other direction is 2, and they don't agree. Okay, now let's go back to this problem right here. So here's what's happened. And the analogous thing over here is, if you just look at the real line, as you approach from the left and from the right, you get two different values. So calculus was one-dimensional, so you just had the line. Now we have c. So now this is our domain. This is analogous to the real line. So now, as I approach this point, z equals 0 right here, I don't have just two ways to approach. So the reality is I could approach I could approach 0 in all different ways. I could approach from that way, I could approach from that way, I could approach from that way. Right, so there are literally an infinite number of ways to approach 0 in this case. And over here we only had 2 in the real line. This is why calculus is easier than complex analysis. That's one reason anyway. So a limit being true in the complex numbers is very similar, is in a lot of ways stronger than it is in calculus, because calculus are only two directions. Here they're an infinite number. So to prove the limit doesn't exist, we just need to find two directions where they don't exist out of an infinite number. So we can, I'm going to come down from that direction, and I'm going to compare it to if we approach from a purple direction. Right, so first of all, I'll do the purple one first, right? The limit as z goes to 0 along the real axis of z bar over z equals, well, the limit of x plus 0i conjugate over x plus 0i. This simplifies down to, oh, this is x minus 0i over x equals x over x equals 1, and I was lazy, I should have put limits in there. So I get 1. So the limit as I approach from this way is 1, just like the limit from how I approach here is 1. Now for the other direction, coming down, right, I could look at the limit as z goes to 0 along the y-axis of this. Oh, that's going to be equal to the limit of 0 plus iy conjugate over 0 plus iy equals the limit of 0 minus iy over iy equals limit negative iy over iy equals negative 1. And that is not equal to 1. So therefore, since they're not equal, the limit does not exist. Just like the limit as we approach from the left and from the right, if they're not equal, they don't exist. So in some sense, it's really easy to prove that things in the complex plane the limit doesn't exist, because you have a whole bunch of directions to choose from. Now, of course, it's only easy to prove that the limit doesn't exist if the limit doesn't actually exist. But we had a lot of choices. I could have chosen other directions. I could have chosen, approaching from a 45-degree angle. But the key idea is the exact same from calculus. And that's all. That's the main point of this. Thank you.